1.9 meters per second squared. Note that I'm putting the units in as I'm going through. I don't just leave it as a number. Okay, they've given you speed and a blank. Fill the blank in with the unit as well as the number. Okay, question 2. The photograph shows a sequence of images. Now, as we discussed in lesson as well, some errors with this, but let's go step by step. So without carrying any calculations, describe how the following can be found from the graph. The vertical distance, I've worked it out. It says without calculation. I didn't see that, so that's my mistake. And it is the area underneath the graph. So I did write that down. The area underneath the graph represents the vertical distance. So area under a velocity time graph represents the distance traveled. The acceleration at y. So that I don't. So this was not required. So I'll just rub that out. Okay, because it says without calculation. So I'll rub that out. So the area underneath a velocity time graph gives us the distance traveled. Okay, now the acceleration, again, I calculated it. It is, and it says without carrying out any calculation. So this is where I needed to read the question. It's the gradient of a velocity time graph. Okay, so the gradient will give us the acceleration, and the I worked out those values, so that wasn't required. So the gradient of the graph gives us acceleration. The area gives us the distance traveled. Now, it says the graph contains several errors in its representation of the motion of the ball. Explain 2 of these errors. I could have picked many here. So as we can see from the picture, the ball is dropped. We know that the speed should be increasing. Okay, so from there to there, the ball is falling, it's gaining speed. Now, speed should be increasing and getting, because it's falling downwards, the speed is negative. Okay, because it's falling downwards, the speed should start off at 0 and get more and more negative. Here we see it starts off at 4 and it drops down to 0. Okay, that is an incorrect representation. So what have I written? The ball initially accelerates, but the graph shows that it decelerates. So if you look at that, that's showing it's decelerating, but we know that the ball does speed up. Okay. Second point I mentioned is that the ball then collides with the ground here at X. Now here it says that took no time. So the time the ball that was in contact with the ground was 0 seconds. Now in reality, the ball is in contact with the ground for a short period of time. Now that means that this line should be slightly angled, okay, and it should take a little bit of time for that ball to change direction and move in the opposite, move upwards. So that's the second point that I've mentioned. So the collision with the ground takes time, but the graph shows it's instantaneous. Okay, so that's 1 mark for each, 1 mark for that, 1 mark for that, 1 mark for that, 1 mark for that. However, there are so many different possibilities here. Okay, so let's work our way through. The lines are not parallel. Okay, so what does that mean? That means that if we look at that and we look at that, this graph should actually look like this. So I'm going to draw where it should be. It should start off at 0 speed and fall and increase in its speed. So that, but minus to show that it's moving downwards. So that there is when the ball is falling under the force of gravity. Okay, we're neglecting air resistance. Okay, so what we've got is, if we now look, that line and that line are the same gradient. Okay, it shows that the ball is accelerating, and the force of acceleration is G 9.81. So that remains constant. So that's what this statement is trying to mention. Okay, so if we look at all the others, in reality, the ball loses speed when it bounces, and it doesn't come back to the same height. We can see that it doesn't come back to the same height. So it must have lost some energy, hence it should have lost some kinetic energy on collision. Here we see that on collision it's minus 4 point, around about minus 4.8 meters per second, and on the way up it's 4.8 meters per second. So as it's hit the ground, it hit the ground as an elastic collision, lost no energy, but in reality, it does lose energy. Okay. And we talked about the vertical line. We talked about the ball starts off with a non-zero velocity to begin with. Okay. And we talked about the deceleration as well. So these are all of the alternatives that you could have written.